Hello, good day. In this virtual class, we'll be looking at how to find the derivative of sec x from the first principle. Okay, here from definition, f prime of x is equals to, as the limit delta s tend to 0, f of x plus delta s minus f of s divided delta s. This is just the simple definition of the first principle. Okay, now we could see that y is sec x. So the appropriate expression for sec x is 1 over cos x. So we say y is equal to 1 over cos x, which is the same thing as sec x. But here, in place of from first principle, in place of our y here, we replace it with y plus delta y. Similarly, that of s is replaced with x plus delta x. Okay, y delta y and x simply means a small change or small increment. So here we look at our function here. We see this become y plus delta y is equal to 1 all over cos s plus delta x. Now we are looking for only delta y here. We need to move y to the right hand side by just adding minus y to both sides, so that this become y plus delta y minus y is equal to 1 divide cos s plus delta s minus y. Okay, so that delta y is equal to 1 minus cos s plus delta s, because y here is simply 1 over cos s. So we replace it with the equivalent expression. Now let's look for the LCM. Here we need to simplify this by looking for the LCM of the denominator of this fraction, which is cos s plus delta s and cos s. So by multiplying through by the LCM, we obtain that this cos s will multiply 1 and this cos s plus delta s will multiply minus 1, and the numerator becomes cos s minus cos open bracket s plus delta x. So the denominator is now cos x cos delta s cos s. Now recall from the double angle of formula in trigonometry. Okay, we know that cos s plus delta s is cos s cos delta s minus sin x sin delta s. Okay, so we replace this expression here with this, and this becomes cos s minus cos s cos delta s plus sin s sin delta s. Divide cos s plus s plus delta x, so that we can also factorize this part of the expression cos x minus cos x cos delta s as cos s into 1 minus cos delta s. Now the next thing is, because we're looking for the ys, we will have to divide both sides by delta x, and if that is done, become delta s, become delta y delta s is equal to cos s into 1 minus cos delta s plus sin s of sin delta x. Divide cos s cos x plus delta s, divide delta s here. Okay, so that this delta s will really affect the numerator of this expression. Okay, so that this become 1, this become cos s into 1 minus cos delta s divided by delta s plus sin s sin delta x over delta x. Okay, the denominator remain unaltered. Okay, here if we assume because we assume that the limit as they tend to 0 of delta s as it tend to 0, we could see that simply that this expression here will become 0. Okay, because if you similarly if you put 0 here and you put 0 here, everything is blown up to become 0. But here of the limit as delta s tends to 0 sin x sin delta s over delta s is simply 1, because sin delta s over delta s, this limit as it tends to 1 from trigonometry is exactly 1. So this becomes sin s. Now we will see that from here, if we put 0 here, this will become cos x cos s, so that the denominator here become cos square s. So the y ds is equal to sine x divide cos square x, because the whole of this numerator now is left with only sine s. So y the denominator is cos square x. Okay, but we can also simplify this by saying this is sine s over cos s times 1 over cos s. But we know that sine x over cos s is equal to tan s, while 1 over cos s is sec x. So that the y ds is equal to uh, tan x sec x. So this is another way we can find the derivative of uh, sec from the first principle, though we can also use what we call the quotient rule. Please, if you like these videos, see them useful, please help me subscribe and also share on your social media platform. Thank you. See you in my next virtual